So today we're going to be talking about molar mass. Molar mass. What is molar mass? So first thing you need to know is that the molar mass is the mass of 1 mole of substance. Well, that doesn't help us really, okay? So you can write in here that the molar mass is the mass of 1 mole, but we don't know what a mole is, right? We need to define what is a mole. So a mole is just a lot of molecules, but a lot in a specific manner. It's 6.02 times 10 to the 23rd. That's that many molecules. So if I count out that many molecules, it's equal to 1 mole. So I'm going to put that on my notes, 6.02 times 10 to the 23rd. That right there is how many molecules are in 1 mole, okay? But the thing is, we use the word mole because we don't want to deal with these super huge numbers, okay? So scientists, namely this dude, Avogadro, he was like, hey, let's come up with this way to talk about a lot of molecules that's the same. And so they came up with Avogadro's number. He was an Italian scientist in the 1700s. And basically what he said is, listen, if we talk about mole, okay, we can use the atomic mass. So the molar mass is equal to the atomic mass, but it has a different unit. It has grams per mole. And I know you're probably thinking this is already confusing, Mr. Imsh. What the heck? I thought that you said it was going to be easy. It's going to be easy. Just bear with me, okay? So sodium, this is using the periodic table. So sodium right here, we already know it's right here. And this number right here is the atomic mass, 2.990, okay? But it's also the molar mass. So that means if I have 1 mole of sodium, it weighs 22.99 grams, okay? So what would the molar mass of carbon be? Well, I just look over here at carbon. Carbon is 12.011 grams. Okay, easy. What about hydrogen? Well, a single hydrogen atom would be 1.008. But if I had a hydrogen molecule, it'd be 2 of those because hydrogen is H2. Okay, so our first one is, what would the molar mass of water be? And that's what we're going to do right here. What is the molar mass of water? And the first step is list the elements. And I've already done this for you, but let's go ahead and put that into the chart. List the elements in the molecule. So for water, for H2O, I have hydrogens and I have oxygens. I've listed them out. I've already done this first step for you. Okay, I list the elements in the molecule. And the second step is I write down how many of each element there is. So write down how many of each element there is in the molecule. So look at this. Over here, I have a 2. I have 2 hydrogens in the molecule. And if there's no number, it's a 1. Okay, cool. I'll let you catch up on the notes. So now that we have the elements listed here and how many of each one, what we're going to do is we're going to write down the molar mass of each element. So write down the molar mass of each element. And to do that, you have to use the periodic table. Okay, so I'm going to come over here to my periodic table and I'm going to look for hydrogen. Hydrogen's right here and it's 1.008. So for right here, I'm going to say 1.008. And then I need to find oxygen. Oxygen's right here and it's 15.999. 15.999. Okay, that is step 3. I write down the molar mass for each one. So then step 4 is I multiply this number right here by the mass. So what I'm going to do here is I'm going to say, all right, I have 2 times 1.008 equals, and you can use a calculator for this. So it'd be 2.016. And then I'm going to say, okay, 1 times 15.99, you don't really need a calculator for that, would be equal to 15.99. Now, the last step I need to do is I'm going to add these 2 numbers up. Okay, so I'm going to add 2.016 plus 15.999, and I'm going to get something that is like, if you use the periodic, technically this should be 15.999. So I'm just going to use my calculator, and I think it is probably something like 18.015 grams per mole. That's what's important right here, is this unit, grams per mole. So my last step right here was adding these products together, okay? So I have just determined the molar mass of water. Again, I write down the elements, hydrogen, oxygen. I write how many there are, 2 and 1. I look on the periodic table and I say how much they weigh, what the atomic mass is. I then multiply across, and add them together, and my unit is grams per mole. We're just gonna work on that today. That's it, okay? We're not gonna do part 2. We are just working on part 1. So we can go here and we can go to our homework and work on that a little bit. Only do the first page of the homework. So it's right here. Click on 6.3. And it is 6.3 homework, molar mass, only the front page. I am going to show you one more example problem that's a little bit tricky because it has this polyatomic right here. So first thing that I do is I need to list out, same exact first step, list out my elements. So I start with Pb, I have some nitrogen, and I have some oxygen. All of those, that's just listing out the elements that are in this entire molecule. Now, Pb is kind of easy. It only has 1. Bam. But let's look at this. I have NO3. So NO3 is a polyatomic ion. So that means it's kind of stuck together. But I have 2 of them. Okay, so that means I don't just have 1 nitrogen. I have 2 nitrogens. And that means I have 3 times 2. I have 6 oxygens. Okay, so it's a little tricky because you need to know the correct number for each one. So now I can look up all of my different ones. So I first start with Pb, lead, it's 207.2. So right in here, I'm gonna write 207.2, whoops. For nitrogen, it is 14.007, 14.007. And for oxygen, it is 15.999. Now I'm gonna multiply them together. This is 207.2. This right here would be 28.014. And this one right here, I'm going to use a calculator for. I think it's just under, I don't know, 94 or something. 6 times 15.999, 95.994, and then I'm going to add it to these other ones. So I'm going to say plus 28.014 plus 207.2 equals, and my final answer is 331.208 grams per mole. That is it.